All right, so remember, as we just talked about with the epithelium, it's going to have a white space, a bunch of cells, and that's it. Epithelium is just a bunch of cells. Now they're fused together so that way things can't sneak between them. They have a basement membrane that holds them in place so they don't get washed away, but they're just cells. I say that like it's not cool, but they're very cool cells. Once it shifts, so as we get past like this line right here, do you notice how there's some open spaces showing up? Well, now we've moved into a different category. And so this is our next area, and that's connective tissue. Now, with your connective tissues, I kind of think of it like the potpourri category of all of your tissues. It's really cool. It's a lot of fun. It does a variety of functions. So don't let the name mislead you when you think connective, that's all it does. It does a ton. So we'll actually put this as miscellaneous. So it does a lot of different things. There's only one area that does what we would consider actually connecting things. And so those would be our proper connective tissues. So a proper connective tissue is doing that job of connecting. And so when you're looking at the proper connective tissues, there's going to be two major categories. You're going to have the ones that will hold things loosely. They'll have a lot of white space in between them. So they have, I don't know a word other than that, looser attachments. And so they're going to have a lot of ground substance. Now the space outside of those cells, that's called matrix. So the matrix that you'll notice will have a lot of white space. So those would be your loose ones. And then you'll also have some that really hold things together well, and those are going to be your dense ones. So with your loose connective tissues, here's your first one. So you can see a lot of open space there. I always think of it looks like spaghetti thrown on the screen. Now, that's another trick for learning your tissues, is kind of find some pattern that you recognize and then make something fun with it to help you remember it. So for me, I throw some spaghetti on a screen. It looks like this. You have fibers going in different directions. You have collagen fibers. Those are the pink ones for strength. You have elastic fibers. Those are the little purple ones that allow for stretch and flexibility, and it comes back to shape. You can have a wide variety of other cells in there. There could be macrophages that can eat pathogens, a lot of different stuff that it can do. So this is your areolar connective tissue. Your next loose connective tissue, wide open spaces. Now those open spaces are actually within the cells. They're storing energy. They're actually storing fat. These are called adipocytes. The tissue itself is called adipose. So for this one, I picture it, and it's weird, and I know a lot of you might not even know it anymore, but the Dixie Chicks song, Wide Open Spaces, plays in my head every time I see a picture of adipose connective tissue, because it's really what it looks like. You just see a little bit of the cell membrane, and then just big open space. The nuclei get squished off to the side so it can store that fat. Your next one here looks like a thorn bush to me. So it can trap things, kind of looks like little lightning bolts in there. Those are called reticular fibers. So what you end up with here is a tissue called reticular. Reticular actually means network. So these thorn bushes are going to also be filled with some cells that are going to be part of your immune system. So you have white blood cells there ready to catch pathogens. And so you have these thorn-like reticular fibers. You have fluid coming by that then could potentially have a pathogen, get stuck in these little nets, and then the white blood cells can then initiate your immune response and then even destroy that pathogen. So it's going to be really useful for immune tissues. So you would put something like this that traps things in places like lymph nodes and spleen. So again, think through locations for each of these by thinking through the story of what is in it, what would it be good at. So if you're looking at, and I probably should have done a little bit better here. So if you're looking back to that areolar one, so if we go back to this one, it's got looser attachment. So you put it in places where you don't want things firmly attached. So you can wiggle your skin around and not pull the muscles underneath. Or if you go to use one muscle, you don't pull the muscle next to it. So you'll put it in between muscles. Adipose, really good for energy storage, but also fat's kind of cushy. And depending on different parts of the body and individuals, you can put some a little bit more cushion in different places. But also, if you think about internally, it's really good to cushion the eye socket for the eyeball, not to hit the bony structure of the skull. Or we'll actually pad the fat around our kidneys. It's actually called a fat pad, which is a really fun name for a structure in the body. Now, if we come over to the dense area, now we're really kind of stuffing it full. You don't see as much white spaces. Now here you have a lot of the pink fibers. So those are collagen. Remember, collagen is the strong structural one. So if you don't know which direction a force could potentially come in, you want to be protective at different angles, you would do something like this. Put the collagen fibers in different directions because you could get poked from different angles. And so this would be a really good example for something that you'd put into the dermis, which is the main part of your skin. So it's right underneath that remember we talked over here, keratinized stratified squamous epithelium. Underneath that, you'd find this thing. So that's the dense irregular. So we have irregular version. So it's going in different directions. And the fact that I'm highlighting that we have an irregular means we probably also have a regular. Now this is when you know the direction of the force is going to work. So this one would be something like tendons and ligaments. You know which way the muscle's going to pull. You know which way the bones are going to interact or move, that joint's gonna, the way the joint's gonna bend. So we'll have the predictability by moving those fibers in the same direction. It looks like a rope. Now, another thing about your dense connective tissues, notice how there's not very much white space? There's so many fibers there that the cells themselves are squished. All you see is the nuclei. You don't even see cytoplasm. So it's a really important thing to think about as we move into our next category. And I'll kind of come back to that a little bit. But when you're looking at dense, you don't see cytoplasm. You just see the nuclei. All right, so dense, regular here. Now, what if you have a structure where you're like, you know the way that they're going to interact, but you also need to have some flexibility, some ability to come back. And that would be somewhere like in blood vessels, especially like the aorta coming straight out of the heart. It's going to get a big surge of blood, predictably, every time the heart beats. And it needs to come back down. But you still want it to have strength of collagen, but we also need to come back down, so we're going to add elastic fibers. And so that's this one. This is going to be our elastic connective tissue. So elastic connective tissue is basically take a dense regular connective tissue and add elastic fibers to it. So you're just adding a feature to something that already exists. So these are your proper connective tissues. They're holding things together. You find them between other tissues. Other categories that you'll see off of connective will be if you're going to make a structure or if you're for transport. So let's do the structural ones first. So under structural, you're going to have two major categories. Think about what makes up the framework of the structure of your body. Probably the one that comes to your mind right away, bone. So bone or osseous tissue. There are two varieties. The one that I have here is compact bones. These are making your long bones, so like the bones that you find in your limbs. And so you see these repeating cylindrical units. Those are actually called osteons. The other category that you can make structures out of is cartilage. And so that's what you see outside of all of these cells is cartilage. Now, cartilage comes in three varieties. I think of the one that's on your screen as like the base model, and that's your hyaline. So hyaline cartilage connective tissue, full formal name, will have these open spaces around cells where you can still see cytosol. So remember I mentioned over here in dense, you don't get to see any of the stuff outside of the nuclei. It's just nuclei squished. Here you can see the cytosol. So those cells are called chondrocytes. That's how you identify a chondrocyte. You can see the nucleus, but you can also see some white around it. So those are chondrocytes, and then there aren't any fibers out there. You just have cartilage. So hyaline cartilage is like your base model. This would be somewhere you need a structure, but that structure isn't necessarily taking on weight or moving around much. So like holding the ribs to the sternum, it's holding them up, but not taking a lot of body pressure. We use it for building the nasal septum in the nose. You also, because it kind of, if you notice not fibers there, it's not going to snag a lot. You use it to cap the bones and joints that move. Now, what if you then have to have the ability to bend and come back, but make a structure like this one? So the ear, external ear, by the way, is called the pinna or auricle, is going to be made out of a cartilage that has to have an extra feature. It has elastic fibers in it. And so again, you see chondrocytes, you see nuclei, you see white space around them, but now we have fibers out there between those cells, and those fibers are elastic fibers. So this is elastic cartilage connective tissue that is different than elastic connective tissue. Elastic connective tissue is in the dense category. It was taking regular, so dense regular, and adding elastic fibers. Elastic cartilage is basically taking hyaline and adding elastic fibers. So think of them as kind of like an add-on feature, a bonus feature. Now, another bonus feature you could do, instead of adding elastic fibers, you could add the other fiber type, which is the really strong one, the collagen. So we could add collagen to it and make it look very fibrous. And that's this one, fibrocartilage. So fibrocartilage is going to have, again, chondrocytes. Now here, the way that they use the dye, you don't really see the white, but you can still see where the cell membrane is around these. So it's not just squished nuclei. So you still have chondrocytes, and then you have that collagen fiber, and it looks a little wavy. So to me, I always say this one looks like eyeballs trapped in hair. And so if you're looking at them, you're dealing with weight. So this would be like in between the vertebrae. You have pressure coming in there on those intervertebral discs, or pubic symphysis, or the menisci in the knee. All places where you have to have a kind of a cushiony structure. You don't want to have just fused bones. Like think about like along that spine. You wouldn't have that flexibility to move. So you'll have fibrocartilage there. So it could be stronger, but it's not as rigid as bone. Okay, so those are going to be kind of walking you through your cartilages there. And then our very last one under your connective is going to be the one for transport, which are your fluid connective tissues. And the one I have up on the screen, for example, is blood. But we also have lymph in our body as well. And so when you're looking at fluid connective tissues, major job there is to transport. So I think a lot of people kind of forget that blood is a connective tissue, but it is connecting things. It's connecting nutrients from one place to another, right? It's delivering them. So if you kind of think of transport as a way of connecting different compartments of your body, think about you put hormones in that blood to then communicate to another location. So it is still a connective tissue. And remember, I did say it's miscellaneous over here. It's a little bit of everything. So if it's not a liner, and then if it's not what we're getting ready to talk about next, if it's not moving things and if it's not creating an electrical signal, then it's a connective tissue.